Sugante, tell me, what is 232? When I mean by 232, what do you mean by it? You know, what do you understand by it? What is 232? A number. I'm talking about the number 232. What does it mean to you?
It's just a number.
It's a number. Yeah. Very good question, right? Okay. So if I say 532, it's a number to you, right? But remember, it has a value. So if I say 232 pounds, it has a value. You understand? So you can relate, oh, okay, 1 pence to 1 pound to 232, it has a value. You know, very well know that. But what does it mean? Oh, you know, okay. So we have a numbering system based on what?
This world.
We call it base 10 or decimal. So simply means that we have 10 fingers. So we go 0, the 0 wasn't there. We went from 1 to 10, but now we have 0 because they found out there's negative numbers in there. So we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. But we have a radix, which is columns, which tells you that the first radix is 1. The next one is the 10 times more than the first radix, which is 10. And the third one is 10 times more than the second one, which is 100. And then the third, fourth one is 1,000, 10,000, and so forth and so forth. So we have a number which between each column in the radix, that number can change from 0 to 9. So if I were say 0 to 9, so number 9 means it's 9. That's it, meaning 9 pence, yeah? But how does it become 10 pence? You add 1 to it, the 1 moves on to the under the column of the 10. Right? That's all it is. The remainder will stay there. If it is 5, of course you took the 1 from there and then you got the 4 left there, right? So it becomes 14p. I understand, right? So that's the way it works. So it is always. So 232 means it tells you that you have 2 100, 3 times the 10, and then 2 times the 1. That's what 232 means, right? So, yeah. Fine, it's a numbering system based on we have 10 fingers, yeah. But let's assume that there was a nuclear holocaust. The human race just aberrated into something, no longer 10 fingers anymore. They ended up with 8 fingers, or 9 fingers to start with. So, and human race has become stupid like the Planet of the Apes, yeah? And what do you say? One is going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The other one is say, 1, 2, 3, 4, 5, 6, 7, 8, 9. And the other one is going to say 1, 2, 3, 4. They finish. They don't have the 9 number. So what are they going to do? They're dumb. They're stupid like the Planet of the Apes. See, they want a different numbering system. They don't want the same numbering system. They want based on, not base 10 anymore, base 9. So what do you got? So your first number is 1. The next one is what? 9. The third one is what? 81. It is no longer the multiples of 10 anymore. It's the multiples of 9.
Not 64.
No, that's if it is 8.
Oh, yeah, sorry. Okay.
Right. So the multiples of 9. Are you with me? So your number is 232. Can that be interpreted in a different numbering system? Yes. So how?
Oh, it's a bit complicated. I'm not mathematical.
So what this means is you can't say you have 232, you can't say 2 because there is no 232. So you would say, now your number is 1, 9, 81. So you'll say what? There's 3 81s in there. So which will you, that's 192 there, right? Yeah? Or whatever the number is, 3 times. And then you will, so the number looks big, but in reality it's the same number, the same equal number. Then I had to work toward this, and then I had to work towards this, and then I say, let's say you were in this patio drinking beer, and the aliens abducted you, and then they got you into it. Now you have this, what you call the computer language, which is the binary system, which is 0 and a 1. And I say, they drill your teeth, and they tell you, hey, you know what? What is your numbering system? You say base 10. It's very easy, 110, 100. They tell, no. It's ours is binary, which is 1, 2, 4, 8. And then you only see one finger. What you can do? 0, you know? Can you interpret all numbers with that? Absolutely. And that is the computer aid. 0 voltage or 1 voltage. That's it. No, that's it. You can interpret anything you want in the world, right? The only thing is, it expands into number of bits that are required to represent the same number.
Yes.
But you can represent anything you want. That's all it is.
Now you tell Sugandhi, what's equal mean?
I know what you.
Oh, I just told already.
How you told her?
Yes. I said 10 is equal to 10. 10 cannot be equal to 5. The problem with them, kids have a problem. What is equal? They have difficulty understanding it. So when the numbers don't come to, they don't really say, no, my answer is wrong. It can't be, no way. Because I started with this number is this, so I'm doing something wrong. The kids don't realize it, you know what I mean? They just don't say, oh, yeah, I'm making a mistake. That's where the problem comes in. They have to know equal means equal. I'm making a mistake, so let me go back and do it correctly. You know what I mean?
Yeah.
That is the problem with some kids. You know what I mean? They just equal means equal. That's it. You can't. More or less equal is different. But in our cases here, pretty close. Okay, 4.15, 4. Whatever 0 is more or less equal. Yeah, that is a different story. But you got to know what is equal means. You know what I mean? The kids. You know what I mean? If you're off number like 4.15 is equal to 3.5, that's not equal. Right? And that is you're off the mark. Right? So they say, Mr. Raj, it's pretty close. I said, no way. Huh? You're not getting the concept of what is equal means,